So let's have a brief introduction to relational database. So database has, as we said, database has a long history and is widely used everywhere. In its simplest form, the simplest database can be just one file. It can be like if you have an Excel spreadsheet, by a simplest definition, it's a place to store data, organize the set of data, right? So it can be considered as the database. But this one file database can handle very, very, very simple tasks. It can manage a small set of data, not the terabytes of data that we talked about in modern databases. The challenge is how to present a large data set in computer. Once you have a large data set, your complexity and the volume both increase. This cannot be handled just by one file. So modern data is complex and large in size. We must have a formal way of design and modeling so that computers can manage them properly. Before 1970s, people used file system for data storage. Even today, when you go to certain like IBM legacy system, they still call tables files. It's just a leftover from the old days when every database table is just a file. So the problem with this approach is that the file system are operated on a file level, not on an individual data level. So there's no clear relationship between files. It's hard to manage. Like I have a custom table. I have a student table. I have a graduate student table. I have a course registration file. I'm sorry. I have a student file. I have a graduate student file. I have a class registration file. What's the relationship between these files? It's hard to understand. And also, data exists there. May easily be duplicated or got lost because there's no restriction. And because of there's no restriction on file, it's also easy to have security issues because you access file in the whole. You cannot manage data individually. So that's a problem with the file system. There were also some early experiments on different database designs. Notably, one is the network database, another is a hierarchical database, but none of them actually got popular. So in 1970, Dr. Cott from IBM proposed a relational model. It's a better way of a database design. And from then on, database that is based on relational model is being called relational database. Relational database quickly gained momentum and it became mainstream. Most commercial and open source database systems today are relational. Like commercially, we have Oracle, SQL Server, we talked about both. And on open source side, we have MySQL, Postgres, both are open. Both are relational database. There are other non-relational databases. Even today, we have like graph database, sounds like network database, right? But the relational database is the mainstream and is the main topic of this course. And so what is relational model? Why relational database get popular? It's all because of the relational model. What is the relational model? It's proposed by Dr. Edgar Cote in 1970, and this is a picture of Dr. Cote. The model basically says even the most complex data set can be represented as relations. And a relation is a set of tuples. Now, what is tuple? Tuples contain manageable information. And the relation is a set containing tuple. Set is an unordered collection. So relation is an unordered collection of tuples. And you can operate relations through what we call relational algebra. And this might sound very abstract. Let's look at the example. We can, for example, a course can be defined as a relation. In each, inside this relation, we have a series of tuples. Each is one individual course. And in each tuple is basically a sequence, a series of elements. For example, DS530, big data and data management. This is the course code. This is the course name. And it has 3 credits. It's on Wednesday, 6 to 10 p.m. This is a tuple. And another tuple is DS620, for example, data visualization, etc., etc. Now, each tuple is a sequence of elements or elements in order. These tuple, when put together in one collection that is not ordered, it forms a relation called course. Oops. When we talk about each tuple is a sequence of elements, we will see that each element has different properties, right? For example, code, DS530, and name is big data and the data management. These two apparently are of a different nature. Code is not for human to read, but it still contains string, contains some of a numerical value. And well, name is completely is a human readable name, and the credit is 3. And all tuples in the relation must have same attributes in the same order. This is the basis, the fundamental basis of a relational model. It only deals with tuples that has same attribute in the same order in the same relation. Tuples in different relation can have different attributes, but the tuples in the same relation, in one relation, for example, in course, must have the same attributes in the same order. If DS530 has 4 attributes, then DS620 must have same 6 attributes in the same order too. Each attribute has its own data type. Like code is maybe it's a 5-digit or 5-character string, whereas name is a long string that can contain anywhere between 1 to 256 characters. And credit is a number that you can add up with. DS530 is 3 credit, is 3. Then a student picking DS530 can also calculate his or her total credit of the semester by adding different courses credit together. So this, but apparently you cannot add the code together. What it does it means that DS530 plus DS620, it means nothing, right? So different attribute has its own data type, and each has their own calculation. For better processing of data, attribute must be defined with the data type. So each relation apparently represents the real world thing, which this topic we will cover in detail later when we talk about how to model real world into a relational model. But right at this point, you can consider relation as a real world thing, something in the real world that maps to the relational model, which is a relation. Inside relation, there are a bunch of tuples. Each tuple represents a real-world instance of that thing. For example, for course, DS530 is a course. It's a real-world instance of course. And for DS530, it has a bunch of attributes. Each attribute represents a characteristic of that instance or that relation. And remember, in each relation, all the tuples must have the same attributes in the same order. So when you try to define the relation, or it actually means you need to describe the attribute. Once you describe the attributes, then you will have a good idea of how each tuple may look like, right? At the time you create a relation, you may not have tuples yet, but by defining attribute, you will know how this relation will look like. And then when you insert tuple, or instance into a relation, you are populating the relation. Like in a course relation, you first define each relation, each tuple in relation must have 4 fields, 4 attributes, which is the code, the name, the credit hour, and the time, the daytime of a meeting. Then you populate the relation by inserting a DS530, big data and data management, 3 credits, Wednesday 6 to 10, each corresponding to an attribute. This is first tuple. Then you insert the second tuple, DS520. Then you insert another tuple, and so on and so forth. That's how you populate the relation. So when you create the relation, there are 2 steps. You want to define the relation, and then you want to populate the relation. And each attribute may have restraints. When you define the attribute, when you define a relation, you need to define its attribute, right? By defining, we are placing restraints and data types and the restraints to the attribute. Each attribute may have restraints, right? Some attributes are like required. For example, for a student must have a school ID, right? And this requirement may not always be ID. Of course, you always need to have an ID, right? But sometimes for school purpose, for different business rules, you may have a requirement for other required value. For example, by default, everybody's social security number should be unique. It should be required, right? And by default, everybody should also have an emergency phone number. And then there will be optional numbers, right? Home phone number, for example. Home phone number, these days, a lot of people don't have home phone number anymore. But all these are like based on the actual relation, and it may change. For example, 20 years ago, everybody has the home phone number, and most likely they won't have a cell phone number. These days, most likely someone will have a cell phone number, but without a home phone number. So this, whether it's a required or optional, these are like subject to the characteristics of the relation. Also, some attributes may be unique. Each student's social security number should be unique, right? Otherwise, there will be some issue. And sometimes some attributes may have boundaries. Each month can only be from 1 to 12. A weekday can only be 1 to 7, or maybe 0 to 6, depending how you define the weekday. But basically, there are restrictions on the value that the attribute can hold. Or like sales, if we just mandate there's no return in the sales table, in the sales relation, then sales value will always be greater than 0. So these are the restraints that you may have. And you can see these restraints are, many restraints are closely related to data type, right? Common data types including text or string or characters, or integer or decimal, or date and time. Sometimes you can also put some attributes together to form a more meaningful attribute. This is called composite attribute. For example, if you put year and the month and day together, you get a date. But usually date, because we use date so often, that people consider this as a single attribute, like date of birth, it will become a simple attribute. But if you think about the source, where this date comes from, you can consider this a composite attribute. But then you can list them as a simple attribute too. Another example is building plus room number. Room number may be repetitive, right? In building 1 and building 2, both can have a room called 101 or A01. Then when you add the building name and the room number together, you will have a unique classroom name, classroom ID. It will be building A, room 101, or building B, room 101. This will uniquely identify a classroom and forms a classroom ID attribute. So this is called composite attribute. Now you may ask me, Do you really consider a date as a composite attribute or a simple attribute? The answer is it really depends on your business rule. Just like when we talk about whether an attribute is optional or not, it depends on the business rule. In most cases, a date is considered a simple attribute because in most scenarios, you will process the attribute in the whole. You will process date as one piece of information. But sometimes you may be more concerned about month or year. In that case, you may want to consider date a composite. Or the other way is also possible, that you just consider year a part of date, and you use this a part of date, partial information from an attribute to form another attribute. These are all possible. Whether you want to define this, which way you want to define it, depends on the analysis you are going to perform on the attribute or on the relation. Normally, you will consider date as one simple attribute though. So how do you represent the relation? An easier way that we have been keep on using is to use what we call a shorthand representation, where you will put the relation name first with a parenthesis followed. Inside parenthesis is the list of its attributes in the order that the tuple will hold the attributes. For example, we will have a student, name, ID, date of birth, address. These are the attributes of a student. Then our ID, name, department, location, these are the attributes of a course. What if, however, I want to access the name attribute, but this name may belong both to student and the course? In that case, we will add the relationship, the relation name in front of the attribute with a dot to separate the relation name and the attribute name. So it will be student.name versus course.name. This way, we will be able to identify which relation this name attribute comes from. This is called qualified representation. We will use shorthand representation in our modeling exercise. So make sure you know how to write representations for shorthand. Make sure you know how to write shorthand representations for relation. So now that we see relations are a collection of tuples, and tuples contains an ordered set of attributes, we can write this in a more formatted manner. All tuples in the relation have same attributes in the same order. So a relation can be simply displayed as a two-dimensional table where each row is a tuple and each column is the attribute of the relation. So this makes a relation very simple to understand and to parse, which means to save and retrieve. That's the fundamental simplicity. This fundamental simplicity is the reason the relational model can be so popular.